Okay, so we're going to talk about, this is day 2. It's the last part of our first half of this unit. So this is now arithmetic series, and we're going to do some partial sums in here. It's important to note that as we move through this, that we are talking about arithmetic series, and that's an important distinction to make, because this will not apply to all series. If you think about what we've done so far, we've done 9-1 was just an introduction to all of the different things that we've been talking about. So we've got series and sequences in general, and now we're just kind of hyper-focusing on this idea of an arithmetic series and arithmetic sequence. So everything we talk about today applies only to arithmetic series and not to just general series. So, all right. So there's a story about a mathematician named Carl Gauss. And I'll just kind of tell you the story, but if you want to just put his name in your notes to try, maybe this will trigger a memory. So Carl was a very energetic young man when he was in elementary school. And his teacher got very frustrated with him because he would not settle down. He was off kind of doing things that he shouldn't be doing. And so she said, well, I'm going to show him. I'm going to give him a problem that's going to take him a really long time to figure out, and that'll occupy him for a while. So she asked him to add the first 100 numbers together. Now, as an elementary school age child, that's quite a daunting task. If you think about trying to add the first 100 numbers together. Instinctively, you would probably start going 1 plus 2 plus 3 plus 4 plus 5 and so on. And it would take you a while, especially because they didn't use calculators then, right? He had to do this all by hand. He surprised his teacher, though, because he came back very quickly. I don't know exactly how long, but probably less than like 5 minutes. And said, I know what it is. It's 50-50. So he added the first 100 integers together and got 50-50. And he did so with no calculator, and he did so as an elementary school student very quickly. So his teacher was kind of like, what? She was flabbergasted. She was kind of upset that it didn't occupy him longer. And so what he did ended up giving us a way to add integers or add the numbers in a series or a sequence together as long as it's arithmetic in a very quick way. So here's what he did. He said, okay, I'm going to pair 1 and 100 together. And when I pair those together, I add those up, I get 101. Okay, then I'm going to pair 2 and 99 together. And when I pair those together, I get 101. Then I'm going to pair 3 and 98 together. And I pair those up and I get 101. And he kept doing this until he got to the point where he got 50 and 51 to add together and got 101. And then he said, okay, well, I know how many of those there are going to be. There's going to be 50 of those. So he said, okay, well, then all I have to do is take that 101 and multiply it by 50. So he's able to take 101 and multiply it by 50 to get the sum of 50-50. So he thought of this big sequence as having some patterns. He said, let's take those last and first numbers and see what we get. And then because it's an arithmetic series, an arithmetic sequence, any numbers that we take that kind of count inwards from there, when we pair them up, those pairs are also going to be 101. So it allowed him to, instead of doing 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100, it allowed him to say, well, there's going to be 50 of these pairs that are each adding up to 101. So I can quickly figure out what that sum is going to be. So his mind worked that way. And what it led us to was this formula. And this formula says if we wanted to add all of the numbers in some kind of arithmetic series together, S sub n, so some number of numbers. That's what n refers to. What we do is we take n over 2 divided by 2. So that's where he got the 50 from. He said there were 100 numbers. There's going to be 50 pairs because I'm going to pair up those 100 numbers with another number. So there's going to be 50 pairs. And then I'm going to multiply that by whatever the sum of the first term and the last term are. So a sub 1 plus a sub n. And that's where he got the 1 and the 100 from. He paired those together. He got 101. He multiplied by the number of pairs. This is the formula that we can then use to find the sum of any arithmetic series. It has to be arithmetic, and that's the key. Something else, any other kind of series, will have to have a different approach. I just want to maybe practice this with one kind of really easy one, and then we'll look at how can we use this if we don't know what the last term is. So give me a number between, let's say, 100 and 1,000. Pick any number between 100 and 1,000. What do you want to do? 600. 600 what? 70. 670. Okay. So let's find the sum of the first 670 integers. Okay. So let's imagine we're going to use his formula here. So we're going to use that s sub n equals n over 2 times the first and the last term added together. So we're adding how many terms together? Well, there's going to be 670, right? So n is 670 because that's how many numbers, that's how many terms there are going to be. The first term is just 1, and the last term is 670. Okay, so we have all of the information that we need to find the sum.